in this recordings or in this class, we are going to look into this algebra part 1. And these are the concepts that we are going to briefly cover it. And I will be mentioning only the key pointers in these things, which are very important in the exam point of view. And also we are going to work on few questions which are from the past year papers as well. So based on these concepts. And in this 2 hours video, so we are going to cover up all these 9 topics. So it starts from the basic things. That's to start up with the introduction to the algebra. And then it also goes up till algebraic fractions, then indices. And when I say equations, it's more or less like a linear equations here, mainly. And also the quadratic equations. So your equations and the equations, so we have linear as well as quadratic, and then graphing inequalities. And here we are not going to talk about the graphing, just inequalities with the 2 variables. We are also going to talk about the number line and stuff. Then we have the sequences. Under sequences and series, we have arithmetic and a geometric series. Then few questions on proportions. Under proportions, we have this inversely proportional and directly proportional, and we have functions. So we are briefly going to look into these things. We are not going to look into each and every concept in depth. I will tell you what are the things that you should be aware of, and I'll be giving you few key notes on these things. Let's make a note on these things. So first of all, when it comes to algebraic manipulation, so the introduction to algebra means you should be aware of. So algebraic terms means I can have the variable to be x, and I can have the constants to be 2. And the variable is not necessarily, it has to be only x. It can also be x squared, x cubed, a, b, c, anything can be variables. And so whenever the operands means you have this plus, minus, multiplication, division, all these things. And we have the variable, constants, and the operands. All these things are combined together. So it forms up an expression, and that's what we call it as an algebraic expression. So we can also say this 2x plus 1, or maybe 4x divided by 3. All these are the example for algebraic expressions. Now, under algebraic manipulation, the first things that you should be knowing is about expansion. So this is under 2.2 algebraic manipulation. So we should be aware of this expanding. So under expansion, so first of all, whenever you have a single variable and 2 variable in the parentheses, so suppose you have 2x times 4 plus 3x. So now this first term, you have to multiply to both of these terms to expand it completely. So it's going to be 2x times 4, which is going to be 4x. Then 2x times 3x is going to be 2 times 2, which is 6. And 6x times 6 times x is x squared. And this is the basic stuff. And the next type of expansion will come is, so whenever you have 2 linear expressions in 2 different parentheses. So suppose if you have it something like x plus 2 times x minus 3. And here you have to do it like a FOIL. So that means, first of all, you have to multiply the outermost terms in the parentheses. That's nothing but x times minus 3, which is nothing but minus 3x. Or we can first of all multiply these 2 things first. So that's first terms in both the parentheses. So that's nothing but x times x, which is x squared. Then x times minus 3, which is nothing but minus 3x. Then 2 times x is nothing but positive 2x. And 2 times minus 3 is nothing but minus 6. And we can add the like terms here. So which is going to be x squared minus x minus 6. And this is how the expansion would work. And even we can expand 3 parentheses, keeping the same logic. So all you have to do is, you have to keep 1 term, and you have to multiply this 1 term with each and every term, whatever we have it in the other parentheses. So even if I have it something like x plus 2 times x squared plus 2x plus 7. So even if I have it something like this, so first of all, I'll be keeping this x and I'll multiply this x to each and every of these terms. So that's nothing but x times x squared, which is nothing but x cubed, then x times 2x, which is nothing but positive 2x squared, then x times 7, which is nothing but positive 7x, then 2 times x squared, which is just 2x squared, then 2 times 2x, which is nothing but positive 4x, then 2 times 7, which is nothing but 14. And from here, we can add the like terms. So the like terms here are 2x squared and 2x squared. And also you have this 7x and 4x. So that will give us the final answer to be x cubed plus 4x squared plus 11x plus 14. And this is how the expansion would work like. And the next thing that we should be aware of under algebraic manipulation is factorizing it. Factorization. So under factorizing it, the first thing is, so whenever you have two terms, you have to think about taking the highest common factors to be out. Just an example. So suppose if I have it something like 3ab minus 6a squared. So out of these two terms, what are the maximum common factor we have it, or the highest common factor we have it? If I look at the numbers, so out of 3 and 6, so the common factor we have is 3. So we can take out 3 common out. And among this AB and A squared, so A is the common factor. We have A in both the terms. So we can take out this A common out. So now I have to use the parenthesis here. So it's going to be 3A times. So if I take out 3A common in the first term, so B will be left. Then minus, if I take out 3A common in the second term, so 2 times A will be left. This is what it meant by factorizing this term. So here, if I talk about factorizing 4 terms now, so suppose if you have it like AB minus 2A plus, let's say we have it something like 2 2b squared minus 4b. So if I have it something like this, so whenever you have 4 different terms, we have to group 2 terms at a time and we have to factorize it. So among AB and 2A, so A is something that I can take it out common. If I take out A common, so I'll be left with B minus 2. Then plus, among this 2b squared minus 4b, 2 can be taken out common and B can also be taken out common. So if I take out 2b as common, so in this first term, so I'll be left only with B, and here I'll be left with minus 2. And this is not the final step for the sum. So among these two terms, now these two things you can consider it as a term. So among these two, we can also take out this B minus 2 common. If I take out this B minus 2 common, I'll be left with A plus 2B. And this is the factor form of this expression. And the last one under this factorization we should be aware of is that factorizing a 3 terms and especially factorizing a quadratic equations. So that's nothing but, so suppose if you have it x squared plus, let's say we have it as 5x plus 6. So if I need to factorize this term, so the first thing that we need to find is we need to find the factors for the product of the first and the last term. So the product of the first and the last term is x squared times 6, which is nothing but 6x squared. Or you can just focus on the number, which is 6. So we need to find all possible factors, and we have to choose one factor which adds up to give us the middle term, which is 5x. So the different factors for 6 is, so we can have 1 and 6, we can have 2 and 3. That's it. We don't have any other factors. So now, because we have this positive 6 here, so that means we should be having both to be either positive number or both to be negative number. Since the middle term is positive, I'm going to keep both the factors to be a positive numbers. Here we have this 2 and 3. So this is the number which will add up to 5. And this 1 and 6 will add up to give us 7. So that's why we are not going to use that. So in that case, I'm going to split the middle term, something like 5x can be split as 2x plus 3x. Now from here, we have to group two terms at a time and we have to factorize it as we did it in the example number 2. And this is what comes under factorization as well. And then if I talk about 2.3, which is algebraic fractions, the important thing that you should be aware of in doing the algebraic fraction is you have to do something like a LCM. So whenever we are talking about adding or subtracting two fractions, however we will be doing it, the same way we have to do it here as well. So under algebraic fraction, so suppose if I have it 1 over, this is algebraic fractions. So suppose if I have, just an example, if I have it 2 over x plus 2, then minus, let's say 4 over x minus 1. So if I have some fraction, something like this, these are known as algebraic fractions. So this 2 over x plus 2 is one algebraic fraction and 4 over x minus 1 is another algebraic fraction. So now we have to think about simplifying this one. So in order to simplify this, we have to make the same denominator. Whenever we have any type of fractions, if the denominators are same, so then we can add or subtract the numerator directly. So in order to make the denominator the same, so for the first term, I have to multiply with whatever the denominator I have it for the other term. So which means I have to multiply and divide with x minus 1 here. And for the second fractions, I have to multiply and divide with x plus 2 here. So now when we do this, so in the numerator, I'll be having 2 times x minus 1. And in the denominator, I will just have it as x plus 2 times x minus 1. And minus, here I'll be having 4 times x plus 2. And divided by, I will be having x minus 1 times x plus 2. These are some of the key pointers you should be aware of under these concepts. That's what I'm trying to teach. So here, since the denominators are same, so we can just keep it as same. And one key pointer to note under whenever you're solving the algebraic fractions questions is, don't expand your denominator until it's your last step. So that's the key rule to follow it. So because most of the time what happens is when you simplify your numerator, whatever the expression you have it in the numerator and versus whatever the factors you have it in the denominator, those things can get cancelled out. So that's the reason. So do not expand your denominator until it's your last step. So in the numerator, so when I expand it, it's 2x minus 2. And here it's minus 4 inside. So it's going to be minus 4x, then minus 8. So if I simplify this, I'll be getting minus 2x, then minus 10 divided by x minus 1 times x minus 2. So in the numerator, we can even keep it like this. So in the numerator, I can take out minus 2 common out. It's going to be x plus 5 and divided by x minus 1 times x plus 2. You can also keep it like this, or you can expand the denominator and keep it. And here, suppose you're instead of 5, if we would have got maybe 2 here, then we would have cancelled out this x plus 2 and x plus 2 and kept minus 2 over x minus 1 as the final answer. So that's the reason. So we should not expand this until it's your last step. So this is the key point that you should be aware of under algebraic fraction. And next comes as indices. So in indices, the rules is something that you should be aware of. The rules go something like this. The law of indices. Law of indices goes something like this. So you have this a power 0. So the derivative of, a power 0 is nothing but, my bad, indices a power 0 is going to be always 1. Then whenever we have a power 1, anything to the power of 1 is going to be a itself. So whenever in the indices, so whenever you have a power x, this a, we call it as the base of your indice or base of your exponent, and x is what we call it as the index, or you can also say it as exponent. And the next law you should be aware of is, so whenever you have a power m times a power n, so this can be written as a power m plus n. So for an example, if you have this x squared times x power 3, this can be written as x to the power of 2 plus 3, which is 5. And then whenever we have a power m over a power n, this can be written as a power m minus n. Then a similar logic. Then whenever we have a power m whole power n, this can be written as a power m times n. And then whenever we have ab whole power m, this power will belong to both these terms inside this parenthesis. So it's going to be a to the power of m times b power m. And one of the most important rule that we have is, the couple of more important rules is, whenever you have a negative power, suppose if you have a power negative m, so this can be written as 1 over a power m. And next, we have something known as radical form. So the radical form is whenever we have this nth root of a power m. And whenever you have it anything in the form of nth root of a power m, we can't really simplify it. So we have to convert it into an exponent form in order to simplify it. So if I want to convert this one in the exponent form, the exponent form of this one would look something like a to the power of m over n. So which means, just a couple of examples. If I have cube root of a power 4, or maybe cube root of x power 4, this can be written as x to the power of 4 over 3. And even if I have square root of x cubed, so if there is no power means, or there is no numbers under the square root means, under this radical means, so by default, you have to take it as 2 because it's a square root. So that's why this can be written as x to the power of 3 over 2. And this is how it goes. And these are the rules that you should be aware of under indices. And the next thing is, so if I talk about equations, under equations, we should be knowing about the linear equations and the quadratics. So under equations, first of all, let's look into linear equation. Again, we are not going to talk about graphing a linear equation at this point. So that we will see it under coordinate geometry. So right now we will just look into forming or modeling a linear equation. That's basically the word problems. And how do we solve a given linear equation? So a linear equation means it could be in the form of, so whenever we have one variable, so under linear equations, the first type of question can come as linear equation with one variable. So one variable means, so suppose you have it something like 2x, a simple example, 2x minus 1 is equals to 5. If I have it something like this, if I say it, solve this equation. So which means you have to think about making x the subject here. So minus 1 goes to the other side. It's going to be 2x is equals to 5 minus 1, or when minus 1 goes to the other side, it becomes positive 1. So it's going to be 5 plus 1, which is 5. And x will be equals to, when this 2 is getting multiplied on the left-hand side, when it goes to the other side, it gets divided. So you can say it, x is equals to 5 over 2 or 2.5. So these types of complex expression, you can have it. And the second one is, whenever we have it with two variables. And this one we also call it as solving a simultaneous equations. So when we talk about solving a simultaneous equations, so the first thing is, if I just take an example, let's say if I have x plus y equals to 4, and the second equation is, let's say I have 2x minus 4y is equals to 8. So I'm taking a very, very simple example here. So these are the two equations we have it, and I have to solve for x and y. So if I need to solve for x and y, there are two methods. One is, so the method one we have is by substitution. We call it as, this is the method of substitution. So substitution means the step number one is choose one of the equation and make one of the variable the subject. So I'm going to choose the first equation and we can make any one variable as the subject. Okay, let me make y the subject. So the first equation is x plus y equals to 4. If I try to make y the subject, which means I have to take x to the other side. So y is going to be equals to 4 minus x. And whatever, let's say this is step number one. And we need to substitute the step number one's result in the other equation. So the other equation we have is 2x minus 4y equals to 8. And we have to substitute this y equals to 4 minus x. Whenever we talk about substitution, so that means instead of y, we have to put this 4 minus x. So it's going to give us 2x minus 4 times 4 minus x is equals to 8. Now, when I simplify this, it's going to be 2x minus 16 plus 4x is equals to 8. Then this is going to result in 6x. And when minus 16 goes to the other side, it's going to be 8 plus 16, which is 24. Then x will be equals to 24 divided by 6, which is 4. So once when you get the value of x, so in order to get the value of y, so we can substitute this x value back into step number one. The step number one we had was y equals to 4 minus x. And we can put 4 here. So that's going to give us y is equals to 4 minus 4, which is y is 0. So when I solve these two equations simultaneously, using this method of substitution, we got x to be 4 and y to be 0. And this is the answer for solving these two simultaneous equations. Now I can solve these two simultaneous equations using the second method. Second method, we call it as elimination method. It is the method of elimination. So that means we are going to think about eliminating any one variable to find the value of the other variable. Of course, irrespective of which method you choose it to solve the sum, you should get the same answer. So in order to solve this question, in the first equation, so figure out what is the variable that you would like to eliminate. So here, I'm interested in eliminating x first. So figure out what are the coefficients. The coefficient of x, coefficient means the number which comes in front of x. The coefficient of x in the first equation is 1, and the coefficient of x in the second equation is 2. So you have to multiply those coefficients in the other way around to the other equations. The first equation, I have to multiply with the coefficient of x in the other equation, which is 2. And for the second equation, I have to multiply with the coefficient of x in the other equation. So that's going to give us, so you have to multiply this 2 to the entire equation. So that's going to give us 2x plus 2y equals to 8. And the second equation is going to be, I have to just multiply it with 1. So it's going to give us 2x minus 4y equals to 8. And here, in order to cancel out 2x, I have to subtract this. So when I subtract this, so 2x minus 2x will become 0. So 2x minus of minus 4y. So 2x minus of minus, sorry, 2y minus of minus 4y is going to result in 6y. And on the other side, 8 minus 8, which is 0. So that's going to give us the result as y to be 0 over 6, which is 0 itself. Now, once when we get the value of y, we can substitute this one in any one of the equation to get the value of x. So I'm going to put it in the first equation. It's going to be x plus, if I put y to be 0, so x plus 0 equals to 4. That will give us the value of x to be 4. And this is the same answer that we have gotten it, even when we try to solve the same question using the method of substitution. And this is what it meant by solving a simultaneous equation. And the next comes as quadratics. So the quadratic equation. So mainly in solving a quadratic equation, you should be aware of few things. There are 3 different methods in solving a quadratic equation. Again, quadratic functions, we will be looking at it in the later chapter. So in this one, it is just going to be a quadratic equation. That how do we solve a given quadratic equation? That's what we are going to look into. And mainly we will be focusing on 2 methods. So the method 1 is by factorizing it. By factorizing. So we have seen an example earlier. That is, we have seen it. How do you factorize this x squared plus 5x plus 6? Suppose if I have some equation, something like this is equals to 0. And if I need to solve this quadratic equation. So by factorization means I have to factorize this by splitting the middle term. So when I try to do that, so the first thing is I have to multiply the first and the last term, which is 6x squared. We can just focus on the numbers. I have to find the factors in such a way that it adds up to give us me the middle term. So that is basically 2 and 3 here. So which is going to be x squared plus this 5x can be written as 2x plus 3x plus 6 equals to 0. And here we can group them and factorize it out. So if I take out x common out, I'll be left with x plus 2. And again, I'm factorizing it. If I take out 3 common out, I'll be left with x plus 2 again. And among these 2 terms, I can take out x plus 2 common. So I'll be left with x plus 3. And this is equals to 0. And whenever we have 2 linear factors which are equals to 0, so that's basically whenever we have the product of 2 terms is equals to 0. So we can equate each factors to 0. So that's nothing but either I can say it x plus 2 to be 0, or I can say this x plus 3 to be 0. So that's going to give us either x equals to minus 2 or x equals to negative 3. So these are the values for x when you solve this quadratic equation. So under factorizing, there are also a couple of other things that you should be knowing it. So this is case 1. You can take it as case 1 when all 3 terms are non-zero. So the case 2 is, so suppose, let's say I don't have the third term. So the third term, so whenever the quadratic equations will be in the form of y equals to ax squared plus bx plus c, this is how the quadratic equation would look like. And in case 2, suppose if c is 0, so that's basically if there is no constant term. So then I will have the equation something like just x squared plus 5x equals to 0. So whenever you have it something like this, don't do the mistakes something like. So usually the student does the mistake something like this. They will do it like x squared is equals to. They will send this 5x to the other side, which is minus 5x. then they will cancel out 1x on both sides, and they will just say x equals to -5. These types of question will be of 2 mark. And if you just do that, you will lose 1 mark. Because whenever you have these types of equation, you have to factorize it and then solve for x. So which means I have to take out x common out here. If I take out x common out, so I'll be left with x plus 5 equals to 0. And again, here I have 2 factors. We can equate these 2 factors to 0. So which means either I can say x equals to 0 or this x plus 5 is equals to 0. So that's going to give us the value of x to be 0 or x to be -5. So this is the right approach to solve it. So do not make a mistake in solving it in this way. And the case 3 under solving a quadratic equation is, suppose the middle term is 0. So suppose the value of b is 0, then I'll take a different example because here I'll be getting some imaginary value. Suppose if I have it as 2x squared minus 8 equals to 0. First of all, I can factorize this out, or I can directly make x squared the subject. So when minus 8 goes to the other side, it's going to be 2x squared is equals to positive 8. And 2 goes to the other side, it's x squared is equals to 8 over 2, which is 4. And the key point to note here is, whenever the square goes to the other side, it becomes plus or minus. So x would be equals to plus or minus square root of, it becomes, if you do not write plus or minus, again, you will lose 1 mark here. If it is a 2 marker or 3 marker, you will lose 1 mark if you do not write plus or minus. So square root of 4 is 2. So that will give us the values of x to be, x is either positive 2 or x is negative 2. And this is how you solve the quadratic equation using factorization. And the next thing is solving a quadratic equation using a formula method. So whenever you have any quadratic equation which is in the form of ax squared plus bx plus c equals to 0, I can use a formula to solve this quadratic equation. The formula, which we call it as quadratic formula, and the quadratic formula would go something like, so this is the method. And the quadratic formula would go something like x is equals to minus b plus minus square root of b squared minus 4ac divided by 2. So in this case, so if I just take an example here, so suppose if you have y equals to 2x squared plus, or I'll take the similar example, which I took it in order to solve it using factorization. So which is x squared plus 5x plus 6. And this is equals to 0. If I need to solve this quadratic equation, so if I compare it in place of a, b, and c, in place of a, we have 1. That's the coefficient of x squared. In place of b, we have 5. And in place of c, we have 6. So if I substitute these things, so it's going to be x is equals to minus b, which is nothing but minus 5, plus minus square root of b squared, which is nothing but 5 squared, which is 25, minus 4 into a is 1 and c is 6. And this entire thing divided by 2 times a, which is nothing but 2 times 1. So x is equals to minus 5 plus or minus square root of 25 minus 24, which is nothing but 1, and the entire thing divided by 2. So x would be equals to -5 plus or minus. So the value of square root of 1 is just 1 over 2. And whenever you have these types of plus minus, you can always just write it as either x is equals to minus 5 plus 1 over 2, or we can write it as minus 5 minus 1 over 2. And this is going to result in minus 4 over 2, which is minus 2, or minus 6 over 2, which is minus 3. So even when we solve this one using by splitting the middle term and factorizing it, we still got the exact same answer. And this is the right answer for this example. And the next concept that we should be aware of is, so graphing inequalities. So under graphing inequalities, okay. So the key point is to note here is, so graphing a linear inequalities. Again, when I say inequalities, I'm not going to graph any quadratics or something. So I'm just going to graph a linear inequalities. So the first things to notice, so whenever we have greater than or equals to or less than or equals to, we have to use a solid straight line. So we need to use solid straight line. And whenever it is just greater than or less than, so use dashed line, dashed or dotted line. So solid straight line represents whatever the points we have it on the straight line, that is also the solution. And dashed lines, whatever the points we have it in that dashed line, that's not the solution. And here we need to shade some region. So whenever you have y is greater than, then you have to shade the region which is above the line. And whenever we have y is less than, we have to shade the graph below the line. So something like that. So first of all, if it is a linear inequalities with one variable, one variable in a sense, whenever you have it, something like x is greater than 2 or y is less than 2, so something like those. So if I say it, x is greater than or equals to 2. And this one in the xy plane, I'm not drawing it on the number line, I'm drawing it on the xy plane. Whenever we say x equals to some constant, that's going to be a vertical line passing through 2. That's the vertical line passing through 2. The solid line is because there is a greater than or equals to. Since it's greater than or equals to, I have to shade the region which is to the right side of this line. So that means my region would look something like this. So that means whatever the points, if you take any point in the shaded region, this linear inequality, all those points will be satisfied by this linear inequalities. And next, if I have y is less than 2. So this means whenever we have this y equals to some constant, that's going to be a horizontal line passing through 2. And since it's less than, it has to be a dashed line. So this is what is 2. It has to be a dashed line. And it has to be something which is below this dashed line. And this is the region. And if I talk about the common region which satisfies both of these inequalities, that's basically this as. It has to be this one. This would be the feasible region for both these inequalities. Now, this is how we graph a linear inequalities with one variable. And if I talk about graphing linear inequalities with two variables. So suppose this is for two variables. Suppose if I have it something like, I'll take a simple example, y is greater than or equals to x plus 2. This is the first equation, and 2x plus y is less than maybe 4, if I have it something like this. So let's figure out how do we graph this. And these two lines will be a slant line. So first of all, if I talk about graphing this equation. So when I say, in order to graph this, we can randomly take any 2 points and plot those 2 points and connect them to form a line, because this is going to be a straight line. So here, the x-intercept is when y is 0, it's going to be -2. So let's say -2 is somewhere here. So x-intercept is -2. Y-intercept is going to be +2. So the straight line would look something like this. So if I have this straight line, which would look something like this, and I can clearly see it, y is greater than or equals to x plus 2. So that means the y coordinates has to be greater than the x coordinates. Whenever this is the case, or y coordinates is greater basically, so in that case, you have to shade the region which is above this line. So that's nothing but we have to shade the region above this line. That means we have to shade this entire region. Something like this. And next, if I have, here we have another line, which is 2x plus y is less than 4. If I talk about the y-intercept is when you put x as 0, you will just get y to be 4. Let's say 4 is somewhere here. And next, when you put y to be 0, you will be getting x to be +2. So let's say +2 is somewhere here. So when you connect them, and here it should be a dashed line, because it's just a less than. So my dashed line would look something like this. And here I can see it, y is less than. So whenever we have y is less than, so that means I have to shade the region which is below this line. So below this line means this entire part. So that's something that I can shade it. This is the region. And this is the solution for the second one. Now, if I talk about the common region which has been shaded by both, so that's going to be this. And this is how we solve any linear, this is how we graph a linear inequalities. And the next concept that we are going to look into is sequences. So under sequences, so sequences means it would form up a particular pattern. So under this sequences, we are mainly going to look into a linear sequence, or we call it as an arithmetic sequence. So arithmetic sequence would go something like this. So whenever we have two terms, whose common differences are same. Any two consecutive terms will have the same difference, means we say that's an arithmetic sequence. For an example, if you have this 2, 3, or 2, 5, 8, 11, 14, something like this. And here the common difference between the first two terms is 3. The common difference between the third and the second term is also 3. Here also it's 3, and here also it is 3. So the common difference is the same. So that's why it's an arithmetic sequence. So the nth term of any arithmetic sequence would look something like, you can take it as an is equals to a1 plus n minus 1 into d, where d is the common difference. And this is what is the nth term. And so the nth term will define, so using the nth term, we can find out any particular term. For an example, in this case, the nth term is going to be a1, which is 2, plus n minus 1 into the common difference d is 3. I can also simplify this. It's going to be 2 plus 3n minus 3, which is nothing but 3n minus 1. This is what is the nth term. So using this, we can find out any particular term. So suppose if I need to find the fifth term. So fifth term means when n is 5, that's going to be 3 times 5 minus 1, which is 14. So from the sequence also, it is the fifth term is 14 itself. Even I can find the 50th term, I can find out any particular term. And this is what we have it here. And the fifth term here. And the next is, we can also have something like a quadratic sequence, cubic sequence. Those things you have to just observe the pattern and try to figure it out. So suppose if you have it as 2, 5, 10, then basically if I have it as 17, then 26, and so on. So if you look at it, the perfect square numbers are 1, 4, 9, 16, 26. And these are not a linear sequence, because when you find the difference between them, they will not be the same. The difference between 2 and 5 is 3. The difference between 5 and 10 is 5. The difference between these two is 7. The difference between these two is 9. And I'll be able to tell you what is the next numbers, because this sequence will follow a pattern. The next number would be the difference between 26 and the next number has to be 11. So that means I have to add 11 to 26. So that's going to give us 37. And quadratic sequence means in 2 steps, you will have this common difference. So here the common differences are 2, 2, 2, 2. And here clearly I can see it. The perfect square numbers are 1, 4, 9, 16, 25. So all those things, the nth term would be just n squared. And we have to add 1 here. So it's going to be n squared plus 1 is going to be the nth term of the sequence. And this is the answer, or this is the nth term for the sequence. And the next thing is, if I look into proportions. So there are 2 types of proportions. One is directly and another one is inversely proportional. So whenever we talk about directly proportional, both the variables will grow together, or basically both the variables will increase together or they will decrease together. So suppose if whenever we say x is directly proportional or y is directly proportional to x squared. So in that case, y is directly proportional to x squared. So whenever we say this, we need to write down y is, this is the proportionality symbol, and x squared should be in the numerator itself. And this is what it meant by y is directly proportional to x squared. And then in order to remove this proportionality symbol, we have to introduce constant, which is k times x squared. And this is how we solve it. If we have any given points, we can substitute it and get the value of k as well. And when we talk about inversely proportional, so when we have this y is inversely proportional to x squared, then it's basically y with the symbol. Whenever it's inversely, you need to write down 1 over. So it has to be 1 over x squared. So it's going to be y is equals to, so if I remove this proportionality symbol, so it has to be k times 1 over x squared. So that's going to give us y equals to k by x squared. And here too, if they would have give us some point when y is 1, x is 2, so something like that. So using that, we can also get the value of k by substituting it in. And the last topic that we are going to look into in this video is functions. So when I say functions, you should be aware of, so functions are basically the y coordinates. So functions are y coordinates here. So which means whenever you have y, you can also replace it with f of x. The different notations for functions is, so whenever I say y equals to 2x plus 1, or if I say f of x is equals to 2x plus 1, or if I say f colon x to 2x plus 1, all these three are exactly the same. The interpretation or basically the meaning of all these three equations are exactly the same. So first of all, if I talk about solving a simple functional equation, suppose if they give you f of x is equals to 2x plus 1. And if I need to find out what is f of phi, f of phi means what is the value of y coordinate when the x coordinate is phi. And when I try to solve this, so it's going to be 2 times, I have to replace x with phi. It's going to be 2 times phi plus 1, and which is going to result in 10 plus 1, which is 11. And next, in the same question, suppose if the part B is solve the equation f of x is equals to phi. This means we need to figure out what is the x coordinate when the y coordinate is phi. So we can replace this f of x in terms of expression. So f of x is same as 2x plus 1, and this is equals to 5. So that's going to give us 2x is equals to, this 1 goes to the other side, which is going to be 5 minus 1, which is 4. So x is going to be 4 over 2, which is going to be just 2. So which means when x is 2, f of x will be equals to 5. This is what it means. And then if I talk about composite functions, so composite functions means we denoted something like f of g of x, or sometimes we also just denote it as fg or fg. These are the different notations that we have it, but more commonly we will be using this first part. So f of g of x means, so suppose if I have this f of x to be 2x plus 1, and I have g of x to be x squared minus 3. Suppose if I need to find out f of g of x, first step we have to do is, See, if f of x is given as 2x plus 1, so first of all, I'm going to replace this g of x with the expression. G of x is same as x squared minus 3. So that means f of g of x is going to be same as f of x squared minus 3. And here the value of f of x squared minus 3 is, your f of x is given as 2x plus 1. So observe this very properly. And here, instead of x, I have this x squared minus 3. So that means I have to replace that x with x minus 3. So that's going to give us 2 times x. This x, I have to replace it with x squared minus 3. So that's going to give us 2 times x minus 3 plus 1. And from here, we can just simplify this. Yes, these are the concepts that you should be aware of. So now we're going to look into some of the questions, first of all in paper 2, then in paper 4, that based on this algebra. Paper 2, first of all. So I'm just going to solve, and which paper 2 is this one is? This is May, June 2022, paper 2 version 1. And this is, you can also use the calculator here. So the first question we have it on algebra is question number 8. So the question number 8 talks about S is equals to half into 80 squared. Work out the value of S when A is 0.9 and T is 4. This comes under algebraic manipulation. That's basically just substituting the values and simplifying it. So that's going to give us S is equals to half into A is nothing but 0.9 and B is nothing but 4 squared. So I'll just open the tab for now here, just to solve this. So I'm just going to use this tab just for simplification. This is nothing but half into 0.9 into 4 squared. Half is nothing but 0.5 into 0.9 times 4 squared. So that's going to give us the result as 7.2. And this is the right answer. And next, rearrange the formula to find t in terms of S and A. So we have to rearrange t. And this one will also have, you should also be aware of this quadratic thing in mind. So when 2 goes to the other side, first of all, it's going to be 2 times S is equals to A times T squared. Then when A goes to the other side, it's going to be 2 times S divided by A is equals to T squared. Now, whenever the square goes to the other side, I have always told you the square goes to the other side means it will always become plus or minus square root of. That is something that we have seen it under quadratics. So that's going to give us T is equals to plus or minus square root of 2s over A. And here, writing this plus or minus is very, very important. So that's why here I need to write it as plus or minus the square root of 2s over A. And that's the right answer for part B here. Next, question number 9 also under quadratics itself. So here we just need to factorize it completely. So first of all, we look into the numbers. So in the numbers, I can see it very clearly. So out of this 14 and 7, so 7 can be factorized out. Out of this x times y and y squared, so we can factorize y common out. So that's nothing but 7 times y multiplied by. So if I take out 7 common out, I'll be just left with 2. And out of x times y, if I take out x common out, sorry, y common out, I'll be just left with 2x and minus your 7 times y squared. So I have taken out 7 common out, and out of y squared, if I taken out y common out, I'll be just left with y. So it's going to be 7y times 2x minus y. This is the factored form, and this is the right answer for this sum. And question number 10 is on sequences. So we have to just find the next term of the sequence for this one. So we have this 27, 22, 17, 12, 7, 2, something like that. So let's find the difference. The difference between these two, so 22 and 17 is 5. It is decreasing by 5. And the difference between these two is also 5. It is decreasing by 5. That's why I'm writing it as minus 5. It is decreasing by 5. So that's why the next term will be 2 minus 5, which is nothing but negative 3. So the next term here is going to be negative 3. And next, find the nth term of the sequence. So we have the common difference here, which is negative 5. So, and it's a linear sequence. So the nth term, we can use the formula, so which I have just told you, which is nothing but a plus n minus 1 into d. And a is the first term, which is 22 here, plus n minus 1 into, and d is the common difference, which is minus 5. And this is going to result in 22 plus, this would be n times negative 5, which is going to give us negative 5. And the negative 1 times negative 5 would be positive 5. And this is going to give us 22 plus 5, which is 27 minus 5. So the nth term here is 27 minus 5 times it. And this is the right answer. And the next question we have it on algebra is on this paper is, it's question number 15. So this comes under indices. So we have this 4 power x, and under indices you should be also be aware of. So whenever you have a power x is equals to b power x, whenever we have the same index on both, or whenever we have a power x is equals to a power y, whenever we have same base on both sides, and we can equate the powers. So in that case, if I have 4 power x on the left side, so I have to think about writing down the right hand side also in terms of 4. So 64 can be written as 4 power 3. So it's going to be 1 over 4 power 3. So which can be written as, so I have this 4 power x is equals to, so if I have 1 over 4 power 3, which can also be written as 4 power negative 3, now I can equate the powers and say this to be x equals to negative 3, and this is negative 3. This is how we have to solve this question. And next, we have this question number 70. So here, of course, the terminologies are different. It looks like it's a question from solid geometry, but the formula is given, the volume is given, and we need to find out what is the radius. So it is just the algebra. So you have to substitute it and solve it. So volume is nothing but 80. So it's going to be 80 is equals to 4 by 3 pi into r cube. So when 3 goes to the other side, it's 3 times 80 equals to 4 pi over r cube. Then 4 pi goes to the other side, it's 3 times 80 divided by 4 pi is equals to r cube. And if I try to make r the subject, whenever you have cube, so when it goes to the other side, it becomes cube root of 3 times 80 over 4 pi. So cube root, I can also write it as the power of 1 over 3. So if I substitute this one, so I'll use parenthesis here. So it's going to be 3 times 80 divided by 4 times pi. And this entire thing to the power of cube root means it's 1 over 3. So that's going to give us the result as 2.673. So 2.673 is the value of the radius. Radius is equals to 2.673 centimeters. And this is the right answer for the 17. And next, we have this factorize it completely under algebra. So whenever we talk about these types of questions, whenever you have 4 terms, we have to group 2 terms each. So 1 minus q and these 2. So for 1 minus q, we don't have anything to take out common. So I'll just write it as 1 times 1 minus q. For the second part, we can take out a negative a common out. If I take out negative a common out, for the first term, I'll be left with 1. For the second term, I'll be left with, since I have taken negative common out, so I'll be left with negative q. And clearly out of these 2 terms, I can take out 1 minus q common. If I take out 1 minus q common out, I'll be left with 1 minus a. So the result, the final answer is going to be 1 minus q times 1 minus a. And this is the right answer for this question. And next, we have this quadratic equation. And part A is on completing the square, and part B, we can solve it normally. So completing the square method under quadratic equation would go something like this. So the step number 1 is I have to take the coefficient of x squared common out if any. And here I don't have any coefficient of x squared here. And step number 2 is we have to add and subtract with half of the square of the middle term. So when I say what is the half of the square of the middle term here, so that's nothing but the middle term here is 8. Half of 8 is 4. So I have to add and subtract with 4, the square of 4. This is what is the first. So now I can group the first 3 terms. The first 3 terms would look like an identity. Either it would look something like a plus b whole squared, or it would look like a minus b whole squared. So whenever it's a plus b whole squared, that's nothing but a squared plus 2ab plus b squared. And here, because we have all these things plus, so that's why it has to be a plus b whole squared. So in place of a, we have x, and in place of b, we have 4. So it's going to be x plus 4 whole squared. Then minus 4 squared is minus 16 plus 10. And this is going to give us x plus 4 whole squared minus 6. Now, when I compare it with this equation, in place of p, we have 4. And in place of q, we have negative 6. And this is the right answer for part A. And next, for part B, we have to solve this quadratic equation. And here I'll be using this completing the square itself. I'm not going to use it by factorization or solving it using the quadratic formula. So this from part A, this expression can be written as, so whenever your part A expression and part B expression matches, always remember it has something to do with part A as well. So x squared plus 8x plus 10 can be written as x plus 4 whole squared minus 6 equals to 30. And when minus 6 goes to the other side, it's going to be x plus 4 whole squared is equals to 30 plus 6, which is 36. And now I'm going to take the square to the other side. When I take the square to the other side, it becomes plus or minus square root of 36. Whenever the square goes to the other side, it always becomes plus or minus. So in that case, x plus 4 is equals to, when I say plus or minus 36, it's basically plus or minus 6 because root 36 is just 6. Now these things can be written as two different statements. One is x plus 4 is equals to either positive 6 or x plus 4 is equals to negative 6. So if I solve it, x is equals to 6 minus 4, which is 2, or x is equals to minus 6 minus 4, which is minus 10. So this is nothing but x equals to 2 or x equals to negative 10. And this is the answer. And finally, the last question under algebra we have it here is, that's w is proportional to the square root of y. Oh, this is the two proportionality thing we have it. So first of all, when I say w is proportional to the square root of y, it's something like this. Next, they say y is inversely proportional to x. That means y with the symbol 1 plus. And they have mentioned all these values, and we need to figure out what is the relationship between these things. So when I say w is directly proportional to square root of y, so I'm going to introduce some constant here. So that's nothing but w is equals to, let's say, k1 times square root of y. And I'm going to figure out what is the value of k1 here by using this point. So if I use this point, so w is, when w is 8, y is 16. It's going to give us 8 is equals to k1 times square root of 16. The value of square root of 16 is going to be 4. So it's going to be 8 is equals to k1 times 4. And when 4 goes to the other side, the value of k1 is 8 over 4, which is 2. So which means the relationship between w and square root of y is, so w is equals to 2 times square root of y. And next year, if I introduce some constant, let's say I'll take it as y equals to k2 times 1 over x. So we know this when x is 4, y is 16. So it's going to be 16 is equals to k2 divided by 4. And when 4 goes to the other side, it's 16 times 4. That will give us the value of k2 to be 64. It's k2, not k squared. That will give us the relationship between x and y to be y is equals to k2 is 64 over x. So now this is something that we can substitute it here. So that was going to give us w is equals to 2 times square root of, instead of y, I'm going to put the 64 over x because we need to find out what is w in terms of x. So it's going to be 64 divided by x. And the square root will belong both to the numerator and the denominator. I can write it as 2 times square root of 64 divided by square root of x. The square root of 64 is going to be 8 divided by square root of x. So this is going to be 16 divided by square root of x. So w is equals to 16 over square root of x. And this is the right answer for this question 25. And these are the questions we have it in this paper 2, which are under algebra. That whatever we have learned it today. And next, if I look into paper 4, Under paper 4, we mainly have questions. So that's, first of all, let's look into this. This is question number 3. So question number 3 is on algebra. So let's try to solve this. This is paper 4. It's a lengthy paper. So Geeta buys X apples and X plus 7 oranges and 2X minus 1 bananas. Geeta buys X apples, X plus 7 oranges, and 2X minus 1 bananas. The total number of pieces of fruit Geeta buys is 30. And find the number of apples Geeta buys. So in this case, all we need to do here is the number of apples that Geeta buys. So these are the number of apples. Here we have it as X plus 7 oranges and 2X minus 1 bananas. So the total number of pieces of fruit is 30. So that means it's basically the X plus 7 plus 2X plus 2X minus 1. That's the number of apples plus the oranges plus bananas. This is going to be equals to 30. If I simplify this, X plus X is 2X, so 2X plus 2X is 4X. Then 7 minus 1 is 6 and equals to 30. And in that case, I'll be getting 4X is equals to 30 minus 6, which is 24. So X is going to be 24 over 4, which is 6. And Geeta buys 6 apples, and this is the right answer for A part 1. And next for part 2, the cost of 1 apple is 15 cents. The cost of 1 orange is 18 cents. And the total cost of all the fruit is $5.55. So find the cost in cents of 1 banana. So the cost of 1 apple is 15 cents. So there are totally X apples. So basically, I can say it as cost of X apples. Apples is going to be, there are 7 apples. We found the value of X to be 7. So it's going to be 7 times 15 cents. And cost of X plus 7 oranges. And this is nothing but X is 5. Sorry, X is 6 plus 7 is going to be 6 plus 7, which is 13. So it's going to be 13 times 18. And next, cost of 2X minus 1 apples. Sorry, 2X minus 1 bananas. It's going to be 2 times 6 minus 1, which is 12 minus 1, which means there are 11 bananas. So it has to be 11 times. Oh, it's 6 apples, not 7. So 6 times 50. So 11 bananas, and each banana, we doesn't know what is the cost. Let me just take it as B. So B is the cost of banana. This is the total cost. And this is going to be equals to, so that's 6 times 15 plus 13 times 18 plus 11 times B. And this will be equals to $5.55. But since all these 6, 13, all these 15, 18, and everything is in terms of cents, so I should also convert this one in cents. It has to be 5.55 times 100. And this is something that we have to solve it. If I try to make B the subject, it's 11B is equals to 5.55 times 100 is 555. Then minus 6 times 15. Then minus 13 times 18. And B will be equals to, so 555 minus 6 times 15 minus 13 times 18. So we can also do it separately, but I just wanted to type it only once. So that's the reason I'm doing it like this. So it has to be 555 minus 6 times 13, then minus, sorry, 6 times 18 minus 13 times, my bad, 6 times 15 and 13 times 18. And this entire thing divided by 11. And that's going to give us the result as 21. So which means each banana is going to cost 21 cents. And this is the right answer for this part 2. In B part 1, so we have to solve this. So when minus 1 is something that we have to take it on the other side first. So when I take that, it's going to be 3 times W over 16 is equals to half minus 1, half plus 1. It's going to be 3 times W over 16 is equals to half plus 1 is nothing but 3 over 2. So both sides 3 and 3 will get cancelled out. So we will be having W over 16 is equals to 1 over 2. When 16 goes to the other side, it's going to be W equals to 1 times 16, which is 16 by 2, which is just 8. And this is the answer. And if I try to solve this part 2, if you observe it, these two questions look exactly the same. So instead of W, I have this 2 power negative y. So which means I can also say this 2 power negative y is going to be same as W. And we got the value of W to be 8. So which means it's going to be 2 power negative y is equal to 8. And 8 can be written as 2 power. So I can equate the powers here. So negative y is equals to 3. So y is going to be negative 3. And this is the right answer for this sum. And here we are talking about solving the simultaneous equations. I can just solve it by elimination. So here the coefficients of q is already the same. I can directly just add them. So 2p plus p is going to be 3 times p. And plus q minus q will become just 0. That will get cancelled out. And 2 minus half is going to be 3 over 2. So this is going to give us the value of p to b. So your 3 will go and multiply it with the denominator. It's going to give us 3 over 2 times 3, which is 6, which simplifies to half. Half is the value of p. Next, if I try to find the value of q, so when I substitute it in here, if I substitute it in the second equation, or maybe in the first equation, it's going to be 2 times 1 by 2 plus q equals to 2. So 2 and 2 will get cancelled out. And when 1 goes to the other side, it's q is equals to 2 minus 1. That will give us the value of q to be just 1. And this is the answer. And part 2, we cannot solve it because this involves trigonometry. And question number 4 also on this functions, and we can solve it. So f of 2 is nothing but, so f of x is given as 2x minus 1. So in that case, f of 2 would be, I have to replace x with 2. So that's going to be 2 times 2 minus 1, which is nothing but 4 minus 1, which is 3. So the value of f of 2 is 3. And then g of f of 2. So this represents g of f of 2. And we have already got the value of f of 2. This is going to be same as g of 3. So g of x is given as 3x minus 2. So in that case, g of 3 is going to be 3 times 3 minus 2. So which is nothing but 9 minus 2, which is 7. 7 is the answer for this one. And g inverse of x. So whenever we need to find the inverse function, the step number 1 is we have to replace the function with y. So it's going to be y equals to 3x minus 2. Then we have to swap the variables x and y. So x will be equals to 3 times y minus 2. Then we have to make y the subject. So it's going to be, when this minus 2 goes to the other side, it's x plus 2 is equals to 3 times y. Then y is equals to x plus 2 over 3. And this will act as the inverse function. So g inverse of x is going to be x plus 2 over 3. And next, we have to solve this h of x is equals to g of negative 2. H of x is here is 1 over x. And g of negative 2 means I have to replace x with negative 2 here. So it's going to be 5 over negative 2. So by the law of indices, whenever we have the negative powers, we have to write it as 1 over 5 to the power of 2. So in that case, when I compare it, in place of x, we clearly have this 5 squared, which is nothing but 25. And next, write down f of x minus h of x. F of x is given here as 2x minus 1, and h of x is minus 1 over x. And this has something to do with algebraic fractions. So here, if there is no denominator, means I have to take it as 1 here. Now for the first part, I have to multiply it with x. So here, in order to make the same denominator, here I'm going to multiply it with x both to the numerator and the denominator. It's going to be something like 2x minus 1 times x divided by x, then minus 1 over x. So when I expand this one, so 2x times x was going to be 2x squared, then minus 1 times x is going to be minus x, then minus 1, and entire thing divided by x. So this is the simplest form. And then we need to figure out g of 2. So we know this g of x is nothing but 5 power x. So in that case, j of 2. So the value of j of 2 is going to be 5 squared, which is nothing but 25. So then we have this j of 25. So which can be written as j of 25 is 5 power 20. So we don't have to solve this because it would be a very, very large value. So we can just leave it as 5 power 25. And then when we have this j inverse of x equals to 4, this thing can also be written as whenever j inverse goes to the other side. So I can also write as x is equals to j of 4. Whenever the inverse function goes to the other side, it becomes just the function. That will give us x is equals to j of 4 is nothing but 5 power. So X would be equals to 5 to the power of 4. So the value of 5 power 4 is 625. And this is the right answer for this sum. That these are the concepts which are important under algebra. And these are the questions we have solved it and which are very important.